Hello. Today we are going to talk. Today we are going to solve lead code tasks uh, on topic shortest path. We uh, considered three uh, three algorithms with support that support weight in graph. Um, okay, and Dijkstra algorithm, Bellman-Ford, and null k BFS. Так. Okay, let's consider some task. Choose most interesting task. Мгм. Так. Okay. It's just an it's just a task on Dijkstra algorithm. Mhm. But with and we in this Dijkstra algorithm we can uh we can change a little bit Dijkstra to that find way with keystops only. Utmost keystops. Okay. Okay, that's good task. Okay, before we start this to solve this task, we solve this. This is just a Dijkstra. Mhm. And let's consider some task on Bellman-Ford or null k BFS. Dijkstra. Mhm. Okay, that's interesting task. И, и так. There's no Bellman-Ford algorithms. There's no tasks on Bellman-Ford algorithm because I don't I didn't see task with no a negative cycle. Okay. I think 4 is enough. Okay. Um, так. We considered Dijkstra algorithm 0k BFS and Bellman-Ford. We don't implement Bellman. We will not implement Bellman-Ford algorithm in this task because they doesn't contain the graph doesn't contain negative cycles. So we must to choose between Dijkstra algorithm and null-key BFS. So null-key BFS works if there's there сейчас there are no the count of weights not huge, but there are too many weights in this task. So we going to implement Dijkstra algorithm. Just very simple Dijkstra algorithm. Where's the Dijkstra algorithm? Okay. So the first is initialize single source, then we initialize our two sets, then we just extract mean and do relaxation. This is relaxation. That's very simple to implement. So but in this task initialize single source will contain not plus infinity, just null. We want to maximize our power values. That means we in this case we just write null. Okay. So to store our graph, we can use adjacency list because the count of edges not so huge. So we're going to initialize our edges. Okay. And we need to can store our edge like not just a number, not just a vertex. We can store vertex and weight. So let's create our graph that contain vertex and probability. the count of vertex will be n. Will be n, and probability will be 1. Will be 1. Not 1. We're going to initialize. We're going to initialize it. Just push. As the graph annotated, we push back. We push back to E. Edges. Just 1 second. We're going to initialize like this. Edges E. Null. And edges E1. Then just suck probe E. Graph is unoriented. The next is priority queue. We're going to store our answers in some array. And with this array, we going to we will store max probabilities, and we do relaxation in this array. Так, как там у нас было? Окей. Probabilities and probabilities with smallest, and max probability start will be 1. Next we create priority queue. We consider priority queue in our set. So set will be our graph, and priority queue will be just and Q will be priority queue. It will contain pair, okay, and comparator must be the weight. Comparator must be weight. So we are going to store in this priority queue vertex and way, but way must be in first position of pair because standard comparator of pair sorts pair consider the first key. So we push to our queue start vertical, start vertex with probability 1, and while it's not empty, we do something. What we will do? Okay, we consider current edge. It will be pair. Q.top and Q pop. Then we try to do relaxation. Yet we consider all the pairs or the edges. Так, double. Ага. Так. We consider all the edges in our graph. Так. Сейчас I think about name variables name. Let it be minedge. Not minedge, max edge. Max edge. Current edge. G. In current node. We place it this current node. Current node will be in second position. So after this we just do relaxation. We have some way that contains here. Max H first. and let's store current vertex. Так, second. Нет, not second, first. And here will be second. Okay, then we just here we consider current vertex, and if current probability less than not less max probabilities less than current probability of this node that stores on current edge. First we do relaxation. We update our max probabilities with new probability. So current probability multiply by current edge second. So we just okay, max, we just update and push new node, and we push just new node. Let me we push так I made mistake, I think. Sorry. We consider pair with max probability. Then if current vertex is equals to end, we just return it. We just need to return current probability. Otherwise, we return it here. If we in this example, we will have to return nothing. So we no probability, so we return here. So. The qpop. But it's better. It will be better if qpop will be here. Consider the current edge. Then we just push. Then we just push what? This, and we push next node. Next node will be in current edge first. I think that's all. Okay. Once again. Ой, слишком много времени. So much time. Once again, it's just a implementation of the Dijkstra algorithm. We do initialize source here. Here we just represent our graph in most convenient way. Here we just do initialization. Then we create our set and push it and push to this set, push to this priority queue some node. Then we extract mean, extract extract edge with max probability. Так, max probability. Then we just then if we locating it and node, it means we have already calculated current probability, max probability. Then we just do relaxation, and that's all. Do relaxation, current edge first. Okay, if less than current probability multiply by I think it will be better if I write what will be here, because it's it's too much, it's too expensive. It's too expensive, or not expensive. Сейчас. Not expensive, I think. So that's all. That's all the algorithm. Do you have questions? I think it will be better if I test it before you ask questions, or or ask questions in chat. You can ask questions in chat. I see it now. Okay. let me read again. What were the constraints here at the end of description? Constraints are not so strong. I mean not so weak, not strong. Okay. Constraints are our solution satisfied constraints. Is satisfied, and let's check this solution with an example. Let's compile with our eyes. Okay, we push back. Here we push back edges. No null one null. That's okay. With suck prop. Okay. We initialize our source. That's okay too. Then we create priority queue. This set just use in theory. In this case, we just store graph and do nothing with them with it. Okay, queue is empty. While queue is empty, I didn't forget about run brackets. Max probability. Okay, let's compilate. We store null, then we pop it and consider edges 1 and 2. Okay, current probability is 1. Current access is null. Current access not equal to end. So we're gonna consider this relaxation. So we take current edge from graph, current edges null 1 and null 2. We try to do relaxation with current probability and current edge second. Current edge second is null 5. Max probability is null. So we write it here and push our probability to the stack. Oh, все, okay. That's all. I notice the solution works. Блин. Так, окей. I see it. Раз, два, три. 1, 2, 3. Okay. If there's one mistake, there are two mistakes too, or not. Okay. It will be better if I wrote code before lesson. Так, ну, vector pair. Do you see the mistake? GN. N
Pair, I think.
pair int
I mean, vector int. No, vector pair int. Vector pair int.
vector
Vector.
pair int.
No, but the first one.
Okay. I see. I see. Thank you. I я чё? Так, вектор. Зачем я пишу? Why am I doing it? Сейчас. Sorry. Sorry.
I think it's vector pair int,
No.
comma, vector.
Uh, okay. Vector. Not.
Yeah.
We consider adjacency list, and we create we contain pairs. We consider pairs. We contain
Okay.
vertex and probability.
Mhm.
Vector of vectors. Uh, so сейчас max probabilities. Max probabilities. Start. Что? Start node. Okay, start node. Ой, нет, no start node. Start node. Okay, start node. End node. Where's end node? Start node, end node. Where's okay? I did I use start? And end node. Okay, run. Так, push. Why am I not do it with these brackets? Okay, run again. Oh, okay, accepted. So I afraid that this solution will not work, but okay, let's submit it. Accepted. Okay, accepted. That's that's okay, but with only 68 oh, 48%. It's bad, but it works. Why is it bad? We just implement Dijkstra algorithm. I think it will be faster because we already implemented here. And second task is about Dijkstra algorithm tool. We changed it a little bit, so you can go for a break. I read this task and I think about why it's so я забыл слово. It's so bad, just bad. It's just a Dijkstra algorithm. It's not um, is it nothing uh, to improve? Here's nothing to improve because it's just a Dijkstra algorithm. maybe push. Нет, push. Push. It's fine. Use push is fine. Maybe you can ask questions. Ah, okay. Okay. Okay, let's consider solutions. Так, то же самое. Okay, there's nothing to improve. Uh, I don't have any ideas how to improve it. This is the same solution. Using heap. We use heap. Priority queue is heap. Why is the same solution? I think the same solution. Why why you use cout? Okay, the next task. You have a break. 1 minute break. Так, let's copy this algorithm. Our algorithm. If you notice how can I improve it, just write to the chat. You know, half an hour on medium task is normal. It's normal for funk interviews, but I have to do it a little bit faster, so I implemented task before. I will implement task before I explain you how to do it. Okay, here is we have in this task we have some constraint with at most key stubs. So here we just can in when we do relaxation and when we want to return our node, we just check this constraint, this and this condition. Okay. We get flights, and we with cost. Here we get flights with cost. There's the same. We create our graph. Then we push. Так. This is oriented graph. Так, let me read again. Okay. Achieve this price. If there's no such rule, return -1. Okay, here's one stop because we have this path with one vertex, so we return 700. The next is stops. Count of stops is 1. Yes, count of stops is 1. Okay, and we return 200. Count of stops is null, and we return. We will going to return. we are going to return 500. That's all. Constraints not so strong. We have 100,000. Wait, one just 10,000. About 10,000 pages. We have no этих петель. Я не знаю, как называется по-английски. Забыл. And okay, there will not be. Okay, there's no multigraph. It's just a graph, just an oriented graph, simple oriented graph. It means we create graph with n vertices. We push this. We push this. Only this. Так. Just null. And here we have null отсюда. No max probabilities. We create graph max mean. Сейчас. Как будет стоимость? Min cost. And here we have infinity. STD, numeric limit. No, it's the numeric limit int just 10 where price 10 to the power of 4. And here we have null. We have to cheapest price. It means in here in the array we have null. On the start node is not start node, it's src, and we have priority queue with what? Not double, by the way. Not double. In constraints. Int. No, int. Int. Okay. 1 second. Price may be double, I think. Price may be double, so we Так, сердце. Okay, price may be double. And that's all. Double int again double int, but comparator is mean we have to do a comparator, uh, or we just use std greater instead of std less, I think, or not. I think std greater is it's okay. Сейчас, one second. Mm. Std greater, not we have to. Так. Std greater is okay. Okay, std greater is okay. Okay, and we push what? We push just null src. We pop here. We pop min cost. Min cost will be min cost edge. Min cost edge. Can't cost. Can't vertex. Oh well, here we have some changes. We have to. One. Mm, we have to create. Arrays that contain stops, I think. And for this array, we are going to check the count of stops.
Question. Wouldn't it be easy to use BFS to create another graph? Then with its graph, which will contain all the graphs, all the nodes that we can go, then use with this subgraph use Dijkstra. I mean,
Okay, you create you consider graph and you launch BFS on it, and
yes,
start node.
from the yeah from the SRS, and
And
you
you
get a subgraph it's which that is the one that you can go with using at most k stops, and then implement the Dijkstra with that subgraph.
I don't understand what you pronounce. BFS for using what? For calculate stops or what?
Yeah, I know. For calculate the node that we can reach.
That we can reach for key stops, for at most
Yeah.
key stops.
Yes. And
Okay. Then
then
we start the extra on
yes,
this
if
graph.
we know that which node we can reach, then use Dijkstra.
It's just okay. It's no. It's solution two. It's solution two. No. But you can change a little bit the extra, and you get the same. You will get the same. But it's two solution. It's solution two. but I think one launch one time Dijkstra is better than launch BFS and then launch then initialize graphs это, then launch Dijkstra on it. So we are going to change a little bit Dijkstra. For example, you can in some task uh, in your homework you're going to, you will change a little bit DFS too and solve the task. It's normal. It's normal to change a little bit a little bit shortest path algorithms. So it's normal. So we will change a little bit this algorithm. So I decided that I store count of steps in some array, and I will going to update it. Okay, the count of steps I will contain an array. Okay. Or it will be better if I contain it in 1 second. I decide what would be better. Okay, just we create min cost array, and then we create min not min, just key steps array. I think it's many ways to reach the vertex, and we will have to contain a lot of arrays, or a lot of different stops for current node. So solution. What will be solution? Better solution. Contain. Maybe we contain. We will contain. Okay. We will contain the count of steps with our priority queue. We can contain struct that contains way vertex and count of steps. That's just that's a little bit difference, but it's very как easy. Так, okay, we contain pass. Okay, struct will be named as pass, and this struct will contain. We're going to contain what's vertexes. Так. Сейчас. I forgot. What will be comparator if we create struct with just with cost in first position? Would it be the correct if we made it as default? I don't remember, but let's check this. Int vertex, where current vertex, and int weight, and int count of stops. Okay. And in this and in priority queue, we will contain the struct with a static greater. A static greater, I think. Okay, okay. And we will push here null, src, null and src. Нет, null, src, null. Okay, let it be like this. Okay, that's nothing to change. That's I think about comparator. I think it's implemented as check struct in lexicographical small lexical order. It's checks cost and check stops and check where. So let's implement it like this: null and src. Okay, and we get pass min cost. No, we min cost edge. Min cost edge. And will contain in this edge we will contain min the pass with сейчас. I think about name. Okay, it's fine name, I think. It's fine name. And we contain, and here we just change current cost. I forgot about cost maybe double. Why am I use not double? Double. Not double. Not double. Okay, not double. Here we have int. Okay, we get current node, current cost, and current stop. Min cost edge. Stops cost where. And in this way we will have to initialize our stops. We will have to initialize our stops as or not. Yes, we will have to in this min cost and min cost and maybe bool stops. Нет, no. We check it here. We check it later. Current node. We we consider current node, and we just, if the count of stops is less than k plus 1 because we don't consider last node. In here we'll have to do just we consider some paths. I think it will be better if I called as edges. Okay, okay, maybe pass. Okay, maybe it's pass. Pass. We consider pass. By the way, I think I understand how can we improve our solution. Так, okay, where is it? Okay, that's all. Where submit? Oh wow! It's just I forgot about this. I hope that you understand what I changed here. I don't. Uh, okay, I that's strong. That was strong. So, okay, max probabilities. We consider current vertex, and we get some pair current edge with just with just mm, vertex and path. Okay. Next, let it next vertex current edge. Not pass, by the way. It's just a pair. Блин, долго. Next vertex, we consider consider when we first I think first and we consider next vertex and next way, next cost, second, and if the count of stops, if min cost current edge, not current edge cost, next vertex less than next cost plus I think, да? Plus what? Current cost. We just do relaxation again. But we check condition that that steps, that count of steps is приемлемо. Count of steps less than k plus 1, I think. K plus 1. K plus 1 or just a k. Так, сейчас. 1 second. 1. Just a k. So. And we update this. We update only this. And we just push to our queue. Next vertex. Next cost. And count the count of stops. The count of stops is what's the count of stops? Count of stops plus now plus 1. That's all. I think I noticed that's all. Так. Wait. I hope that's all. You know, it's hard to speak English and write this code very fast and explain what am I doing. It's really it's really easy to get mistake. Так. Let's check it. Let's check our solution. Так, there and cities. You're giving integers. By the way, medium, would it be medium or hard or easy? It's just the algorithms that we use. It's nothing. it's just the level of algorithms. Okay, there are entities and connected by some numbers of flights. You are given an array flights from to I price. Vector of we create vector of vector. We contain from to I and price I. And okay, you are given integers. Return the cheapest price. If there's no such road, return 1. Return -1. Return. So we okay, constraints are satisfied. I already checked it. It's not very weak constraints. So let's check with our let's compile with our eyes. I don't want to get by the way, what is it? Okay. I thought I already ran this task. Okay, we have min cost, we have n, and I get a little bit сомневаюсь в этом. A little bit confused about this, but I hope I do it right. do it correct. Okay, we push null and src here our initializer of priority queue. Well, I think this algorithm works. Let's check this. Okay, we have null 1 3. We pop null, then we check this. Okay, then we check this. Так. Ой, let me check in quietness. No, 1 and 3. Okay, I see the mistake. I didn't change this. It's okay. It's very bad that I noticed that. Now, okay. Do you have questions about this implementation? Okay, I implement. I For the next time I will implement uh, code. I I mm, I wanted to show you how to solve task by how to solve task on interviews. So in interviews, so you just write the code, then you again write, then you again read description, and you compile examples with our eyes if you have any time to do this. And okay, if you have any questions about the code, about uh, what am I doing here? By the way, in place. Here I in place. In place.
Question.
Mm-hmm. I
In the part of when you're asking about current cost plus next cost less than min cost next vertex
mm-hmm.
and current stops plus one,
Mm-hmm.
should it be equal to equal s k?
Uh, should it be equal to what? SK?
Equal less equal k.
Uh-huh.
Yeah, exactly. In current steps.
Here or current stops. Current
Yeah, yeah,
stops. Uh-huh.
yeah.
Current stops plus one less than K. Uh,
Less equal shouldn't be.
I fixed it. Just less equal, less or equal. Let me think. Mm, mhm. Um, no, I think because here I have to do this or not. Just 1 second. I think here and here, here and here. Mm. Mm-hmm. That's okay. You're right. I think you're right. Uh, Сейчас. Mm, I think you're right. Okay. Thank you. Um, Thank you. Так. На чем я остановился? I check. I fix this. So that's I think that's works, but uh, that's work, but I'm very afraid about run. Okay, edge size. Where? Edge size. Flight size. Flight size and what? Ага. Блин, почему? Flights, 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 flights. By the way, min cost 10, 10 to the power of 8, 4, okay. Так, okay, here we have some troubles. As the degrader requires template argument. Okay, I don't remember what's template argument. As the degrader. Uh-huh. T. I think it's pass. And I think we have to do okay. Okay, you have operator. I I read about this and I think it's already implemented in C++20, and here we have code on C++20. Mm-hmm. And we will have to. Where is our struct? Where is our struct? Here. And we have to pass. I. Hmm. I think it will be works because, or we will have to do comparator in here. Okay, default arguments. Так, ну, сейчас one second. I think we have enough time. We haven't enough time. The best way to solve more tasks is uh, do it before solve it before seminar, but I show you how to check your solution. Okay, I sent you this code a little bit later because I don't remember how to. I think like this operator less or equal. It's nowhere. It's new feature C++. Operator. Что там? Default. I think. Okay. I think it's not works. I'll check it. Да, неужели? Нет. No. Ага. Окей. I sent you this code a little bit later. So that's all, I think. We will consider this task. Okay, let's consider this task. This spends no much time, no no huge time. So so you have agreed. You have to uh, go for from one cal to my m minus one and minus one cal. Something like something. In this example, you can turn your arrows, and you get one. Mm, just you get one cost plus one cost. For this example, uh, we go plus one, then we go plus one, then we go plus one here, and we reach this cal, so we get free cost. Free cost. Here we have null cost, and here we have uh, one cost. So how to solve this task? This task is very как сказать, it's very easy, despite that it's hard, because we can solve it. Just we can consider the Dijkstra algorithm, for example, and when we want to go in correct direction, we just uh, suppose that edge that the edge that edge is one of cost, and if we go in right direction, we have null cost of edge. So you notice that if we launch Dijkstra, we get our answer. Do you have questions? We have null cost or one cost on edges. Only null and one. So in null k BFS algorithm, I told you about that. If we have not if we haven't um, much values, then we much values of weights, then we apply algorithm null k BFS. So in null k BFS we get now O n k plus m complexity, where k is the count of weights. So here we have only two weights, so this null k BFS works much faster than the Dijkstra algorithm. In the Dijkstra algorithm we have O m log n complexity. Here we have O n plus m, because k is constant, it's equals to 2. Okay? Do you understand that we just apply null k BFS and get the answer on this cal in cal n minus 1 m minus 1 n minus 1. Так. Who is here now? Who is here? Уже все ушли? I hear you. Ага. Pinicho. Do you understand or not?
Yes, yes.
Okay. That's good. So we just launch null one BFS algorithm in this task, and we get the answer. Here we have you notice that you have walls, but if we have wall, you just mark the edge as one, mark the weight of edge as null, as one, or if we have any edges, any walls, we just take one, take null. It's the same here and here, the same um, solutions, the same um, easy solutions. Okay, I think that's all. Okay, I implemented this task and this task and this task uh, and in the previous seminar we consider another task and I implemented and I will implement it and I send you a code. Okay, and you always you can answer questions in chat and I will answer on them. Okay. Okay. About lectures too, even first lecture. So that's all, I think. Goodbye.
Goodbye. Thank
Спасибо,
you.
до свидания.
Mhm.
Thank you.
Mhm.